Hi, good evening, guys. Good afternoon, actually. Are you able to hear me clearly? Okay. Where are the other guy students? Would they be joining in soon? Can someone post that on your local WhatsApp group that we would be starting the session in another 5 minutes? If somebody can, please do that. We'll wait for another 5 to 10 minutes and then we'll begin. Okay, chalo, let's resume from where we left in the last session. So we were working on the statistics ka part. I think there was still some question left to cover. I'll share the PPT and we'll get started with that. Sure, Akshat, I'll do that. Huh? We'll go through that discussion. Yeah. Everyone is able to see the PPT that's visible. You guys can just give me that information. I guess it's visible. All of you could do have the visuals of it. Okay. These all things I think we ended up covering in the last session. So these were the examples for mean, median, and mode, and then the questions. I did that. Just tell me which was the last question we were on. We discussed then the idea of standard deviation, the properties, and then we saw this as well. Quartiles and percentiles, right? Okay, so all right, we need to just let's quickly run through the idea of quartiles and percentiles as as such requested. Let's just have a small recap of that again. So extending the whole idea of how uh, a median works. So we saw that a median is the midpoint, right, of the set of observations. Like it find out, it gives you the point which splits the whole. Yeah, I know, Shamya. We were on the normal distribution, but Akshat has just requested to run through the basic, of the quartiles once again, the idea of quartiles. So I'm just doing a quick recap on that, right? The concept of quartiles and percentiles. Okay. So just like we saw working out on the quartiles, right? So a quartile values are the one which splits the whole data into four equal groups, right? So Q1, Q2, and Q3. Q1's your first quartile, which would divide the first half into equal parts, 25% and 25%. So you can say Q1 is the median of the first half, right? As we saw. Q2 is the median value, which again splits the second half into 25, 25, the Q3. So Q3 turns out to be the median of the second half. So you look at the left and see how many observations are there to the between the first, right from the first till the median value. Take that group and uska median find karenge, so we get the first quartile value. Similarly, you take the median and the the largest value, and uska difference find karenge, so that would give us the third quartile value. So overall, we see there are three quartiles: Q1, Q2, and Q3, right? Q2 is the median itself, and the other two are the medians of the lower and the first half and the second half. Right. Now, on the similar lines, sorry, if we need to work on the idea of percentiles, so let's say I have again the set of say observations starting from here, extending on till xn. Right. So we have right from x1 to xn. Okay. All the observations there. And let's say now we want to distribute, or just like we were splitting it into four quarters, now we need to split this into, let's say, smaller parts of 100. So I would define the first value we call as the percentile. Percentile comes from the percent, which is like per 100. So we are splitting this into the groups, 100 groups, right? So we need to make 99 such splits. So there would be 99 different percentile values, because you need to create 100, equal groups uh, for the entire set of data. So we need to cut it 99 times, because the last cut would give you 2 points. So the first percentile or P1 value would have the data split it in the ratio of 1% to the left and 99% to the right. Okay, so P1 will have 1% and 99%. Similarly, P2 will have 2%, 98. P3, third percentile, would be 93%, 97%, like that. You continue that. Right, so if you would see, that's P50 will have a 50 and a 50 split. You're going to have a 50% on the left side and 50% on the right side. So you see the 50th percentile is also the median value. So median is also referred as the second quartile or the 50th percentile. So 50th percentile value is the one which would have splitted the left right in the ratio of 50% to 50%. Okay. Likewise, you would go further on finding 60th, 70th, 80th, 90th, 95. The last percentile value that you can have here is P99. So therefore, if you take the 99th percentile, you would see that split is in the ratio of 99% to the left and 1% to the right. Okay, so there are 99 percentiles values. Okay, and that would be generally splitting it up, the whole data, into 100 equal portions. Each portion would have 1% of the observations. Okay, but the spread of that could be different, just like we saw in case of box and viscous plot. That represents the different spread depending on the different spacings you have between the first and the last value for that particular quartile interval. The same would go for this one, although since there are too many splits here, so there's no uh, graphical representation of that. We just usually see is as the percentage on that one. Between quartiles and the percentiles, there's also a concept of deciles. So quartiles like 4 quarters, so 3 quartile values. Similarly, deciles are the set of numbers which divides the whole data set into 10 equal parts, 10 portions. So there are 9 decile values, right? So the first decile would be 10%, 90%, 20%, 80%, and so on and so forth, right? Your median again turns out to be the fifth decile value. which will have a 50-50% split on the either side. So median is second quartile, fifth decile, 50th percentile, and all that. Okay, now the idea on a GRE when it comes to percentiles, I've hardly seen any question which is related to percentile. Mostly they covered the quartile values because it's easier to calculate the quartiles, right? Percentiles are a little relatively, you know, generally if you're dealing it only with the integral, with the discrete integral set of data, okay. So if you need to find out a relative percentile value, you just take it as the fraction or that much percent of the spread. Okay, so there are certain approximations that would creep in there because you have to take that corresponding percent fraction of it. So if I suppose if I have to find out what is the 45th percentile value, right? So of that spread, you know, I have to see a point which would which will have, you know, around 45% of the observation on the left side and the remaining 30, you know, 55% on the right side. So I'll have to find that proportionately, which, you know, in some cases has to be approximated, not a very accurate way of working out. So that's generally not, you know, what you would see on the test. Now they expect you to know about the whole understanding of the percentiles or how the whole logic works. So it's always seen in integral form, right? So we would have the largest percentile as 99. You never have percentiles expressed in decimals like 99.5, you know, 76.4 percentile or so. It's either going to be a 74 percentile or a 75 percentiles. They always take integral values. That one, of course, positive integer values. Okay, they are never decimal, they are never negative. Okay, we'll see. So in that context, as you have seen, there is a lot of decimal percentiles which are awarded on CAT, right? You'll never see a decimal percentile awarded on GRE or a GMAT because they actually follow it by the rule, you know. Uh, that depends on actually, you know, how you are working out on the logic. So let's say if take an example or why the IM people uh, do allow a decimal percentile. Okay, and they also give you 100 percentile as it, you know. So you see there are a couple of 100 percentiles every year who score uh, over there on the CAT. So last year there were something around 13 or 14 of them. Okay, 4 or 5 of them are my friends itself. Okay, so I know exactly, you know, if you compare their scores, they all have different scores. Okay, and still they get 100 percentile, right? It's not that if they have 100 percentile, they'll all have the same scores. You would see they have different scores and all that. Now, what happens when you're calculating these percentiles, or why, you know, you see, I'm peoples are not fools, of course. So there's definitely a logic behind why they go and award that. So that would make it a little more clear on the whole understanding of the logic of the percentiles and how this that works. So let's say if there are 100 people who appears for a test, right? And let's say everyone got a different score. There's no repetitions happening. Then how many students would lie in the top 1%? So someone who gets a 99 percentile. How many people can get a 9 percentile, 99 percentile in this case? You have 100 people, all of them have different scores. So what is the percentile you will give to the topper? So the top scorer would get what percentile? Solve it logically. Okay, that's why I'm not writing any formula here, because generally if there would be a question on percentile, it would be more or less related to be solved through logic than formula. So what is a percentile? You will give it to a top person, the top person, you know, the topper. And so I have to see what percent of the total number of people have their scores less than 100, right? So out of 100 people, okay, he see there are 99 people जिसका score उससे कम है, 99 out of 100 people have their scores less than the topper, the highest guy. So usually the percentiles are always seen as the percentage of the number of observations which are less than that particular value. So let's say he got 100 on 100. The last guy got 1, the second got 2, 3, 4, 5. These were the scores, obtained by all these 100 people. So the topper is 100, this next guy is 99 and then 98, and so he sees there are 99 of the people who have their scores less than him. So therefore, he would be the 99th percentile, right? So he gets the percentage of 99. Now let's say if there were 1,000 test takers. I'll I'll try to explain it from the logic of the IAM. So what they do, what they're trying to do there. Now let's say IAM decides that at least for their interviews, they want to call the top, let's say 1% of the people. Okay. So if there were 100 test takers and their criteria is, okay, I'm just going to call only the top 1%, right? So they will see there's only 1% among the 1%, the top 1% region. I'll say, okay, there's one guy, let's call him. He's the highest guy. So what they try to do is differentiate people, not just only on the basis of the scores, because it's just kind of a translation. So instead of awarding them ranks, because ranks are uh, a clear, differentiator. So generally there comes out some sort of a discrimination where you can say, oh, you are 56th rank, I am second rank, right? So when you give it the ranks, they actually clearly defines your position among the total. So sometimes it would not be a very good idea of presenting the data in that way. That's the reason, the rank system has been replaced by the percentile systems, where they won't tell you exactly what your position is. They would just tell you how many people have their scores less than you. So psychologically, it's just like more of a feel good factor. So if you're getting, an 85 percentile, it doesn't tell you, okay, where you are, but it just, helps you to understand, okay, oh, there are 85% of the people, iska score mere se kam hai. All right, so you still feel good about it. Although, you're not going to land up anywhere with 85 percentile on CAT, but still, like, okay, I'm among the top 50%, 15, I mean, I'm among the top 15% in the country. Than actually giving you a rank and saying, oh shit, they're just like, 16th rank on the overall. Not even the 16th would be just much more, lesser in the thousands when you go to that one. Some 20, 10,000, 20,000 rank, which would still be at the 85th percentile if you were. Okay, so it's just another way of writing it down. Now, as the number of test takers would grow, the number of people in that would also grow, right? So I would say, okay, if there were 1,000 people, then how many people would lie in the top 1%? Now, instead of 1, now I have 10. Okay, now how do I differentiate between these 10? 10 is still good. Okay, they say, fine, out of 1,000, I have 10 people who are among the top 1%. Let's call them for the interviews. Chalo, unko bulate hain. Okay, because I just want to have only few limited number of people just going to interview karna hai. Right. Now, let's say there are 10,000. Okay, if there are 10,000 people, it's still in the 1%. This is the same interval, but now you have 100 people. So if I take the top 1% of this 10,000, I will have 100 people. See, 10 is still fine. I can say, okay, these 10s are, good, and I'll just bring them out. But then when it becomes 100, it becomes a lot more difficult task. I would say I would be still okay with calling only 10 people. Okay, but I don't want to call too many of them. So now among this 100, I need to further filter it out because I want to call only 10. I don't want to call more people. But if I was just taking the interval of 1%, as the number of test takers grows, the number of people in the 1% region will also grow. It's like if, you know, I guess you all are familiar. Okay. It's like the same local train when you travel in the afternoon. when the compartment is आराम से थोड़ा खाली, so you can walk in easily. You can also find a seat. Lucky enough, you get a window seat also some of the times if it's just the starting boarding point. But imagine if you're getting into the same local compartment during the peak hours, right? Same space, but now it's just totally crammed up with so many people because the total number of travelers has increased multifolds. It's the same thing that is happening here. As the number of people keep increasing, right? The number of people in the top 1% also keep increasing. So what they would do is said, I don't want to call these 100 people. I want to call only 10% or only the first 10 of them. So I would go for a smaller portion of it, right? So if I'm looking at, let's just try to make it a little more better. So I'm just stretching that 1% per region. Now I'll go for a small fraction of that. Let's say I call only 1/10 of the top 1%, which will be 0.1%, because 1/10 of 100 would give me a 10, right? So what should be the guy here? What should be his percentile? Then he should be 99.9, because I want only 0.1% of the list. So therefore 100 minus 0.1, which will be 99.9. So this guy is going to be the 99.9 percentile, right? Now imagine if you have 1 lakh test takers, right? So you will have 1,000 people, you know, in the 1%, and even in 0.1% earlier, which you had 10. Now again, if you take 0.1% of this again going to give you 100, another 100. Okay, the problem becomes even more complex. I mean, I just trying to filter out. I was looking at calling only 10, but now even in the point 1, I have 100 of it. So I need to further go down and filter it out. I'll say, okay, I'll take now 1/10 of the 1/10 of it, right? So therefore, now I'm gonna go to 0.01% of the top. So 0.01% of the top would be a 99.99. Right. So I'm gonna reject the others and pick these top 10. Okay. But then comes the question that what I'm rejecting and what I'm selecting, is there a substantial difference between them? Because the test is supposed to be a kind of an indicator. It's a kind of an indicator, or you can call as a differentiator, which could tell me, okay, these are the people who are capable. These are which will still need more practice, to come up to that level. Now, I can clearly say, I can clearly differentiate between a 95th percentile guy and a 99 percentile guy. Okay, but that difference would reduce, of course. When you are comparing a 99 percentiler and a 99.9 percentiler, you won't say there would be a substantial gap between the abilities of these two, and this would further, reduce if I'm comparing a 99.99 percentiler with a 99.96 percentiler. Is there going to be such a big difference between them? It would just be one question that possibly you would have got wrong. You would have got a negative, or maybe, one less question that he attempted. It wouldn't be even less than that. So the problem is, how much do I go for? How much do I differentiate? Because as you're adding more and more decimals to it, it's just because you're trying to refine your process, you're getting people with the same calibers, same aptitude in that interval. So saying I'll take only this and reject the other is not a good differentiator there, because what you're rejecting is more or less the same sample of what you're selecting. Then on what basis you're saying, okay, it's just this top one and then the other? In fact, you should have done a lottery in that case. Okay, so there comes the problem. So there they say, if I go to the third, let's say if number of people increases further, and I need to go for the further decimals. So they come up, they say, all right, the maximum we go only to the two decimals, that's 99.99. We are not going to go with the third percentile differentiator because ideally, you know, people with the third percentile, the third decimal place will not be, having that much difference in their aptitude as compared to with the 2% or the two decimal places. So anything that goes beyond 99.9, so if there's someone with a 99.993 or a 99.995 or maybe 99.999, they just round this off. It's a rounding off process. They round off everyone to 100. Okay, although 100 percentile doesn't make sense if you would see. It's just a rounding off mechanism. Right. So you see that's why these top 100 percentilers, they have different scores. Because they would differ in the third decimal. But since they've just all been rounded off, I need to keep it only to the two decimal. They're all just given 100 percentile value. So that brings up the top cream of it. But it's not that they all have the same scores in there. So there's nothing wrong with the process because there are too many test takers, and test is one of the most important criteria of your selection. Unlike, that happens on a GRE or a GMAT where test stands only 25% of the chance. The weightage of GRE or a GMAT for your admit is only 25%. The other 75% is divided into other components. Whereas if you look at CAT, it makes your nearly 85% to 90% of your chance. I mean, if you don't clear CAT, you won't get a call for your GD and PR. So that's why the test is so important. It is an eliminator. It's something that you use as as a filtering process. Okay, GMAT is not a filtering process. GRE is not a filtering process. It's more like a criteria, and that's why you need to go substantially very, very accurate when you're using the test as a filter. That's the reason why you have the decimal percentiles on CAT but not on GRE. So they would say, okay, I don't care, you know. So I would just look at in the top 1% of the people. So if there's someone with a 332 and there's someone with a 337 or a 328, okay, if they all are in the top 99 percentiles, if they all are like, on a, in the top 1%, I don't care, come over. I will check them on different parameters. So that's why they don't bother much getting into the very detailing of the scores. They are okay with the entire lot in the first 1%. So if you look at on the GMAT as well, so it's anyone who scores from 770 to 800, they all get a 99 percentile. So whether it's a 770 or a 780 or 790 or 100 or 800, it doesn't matter. The same goes on your GRE as well, right? So a 339 and 340 or 337, there's not much of a difference. They're just seen in the same way. Whereas 3 marks difference on a card would have made a significant difference in your percentile. Right. So that's the whole idea of it. Right. Now, technically, if you look at it, 100 percentile doesn't make sense. When you say 100 percentile, it means, the percentage of the number of people who have their scores less than you. So if you get 100 percentile, which means you have 100% of the people who have their scores less than yours. And that 100% also includes yourself, right? So theoretically, 100 percentile doesn't make sense. As I said, it's just a rounding process. Whereas a 0 percentile definitely makes sense. So someone who gets a 0 percentile, what does that mean? Can we award 0 percentile to someone? Think it logically. Is it possible to give a 0 percentile to someone? If someone gets a 0 percentile, what does that mean? There are 0% of test takers which have their scores less than him. So 0% of the people, that there is no one, who has his scores less than this guy's scores or my score. If I'm a 0 percentiler, that means I don't have anyone who has his scores less than me. So if that's the case, what does that mean? I am the last guy, right? I'm the, I'm at the end of the queue, right? So therefore, 0 percentile does make sense. 0 percentile would be the person who is the last or the least scorer there. Okay, but 100 percentile will not make sense. Now, see again, and percentile is always about the scores. Okay, it's very different from the whole idea of the percent. So let's say if instead, again, 100 people appeared on the test, correct? And they all had different scores. So 1, 2, 3, 95, 96, 97, 98, okay, 99, 100. So what is the percentile you will assign to the guy who's got a score of 96? You have to see the percentage of people less than him. So there are 95 people who have less than him, so he's going to get a 95%. Perfect. Now, that's the reason why percentiles are seen as a less than case, because I know there are 95% of the people, whatever scores they have their scores less than me. So that means I belong to the top 5%. Okay, but where I am among those top 5%, that is now a question to be debated, because that would change. That is not something which is constant. That is not something that I can answer definitely. So in this case, if I look at my position in the top 5, what is my position? If I'm looking at the top 5 people here, what is this? What is my position in here? Right. So there are 5 people in the top 5, and my rank in that case is 1, 2, 3, 4, 5. So fifth rank, right? So I'm at the fifth rank here, right? Now let's say instead of this, the situation was you had 100 and 100 here. What would be your percentile still? Would it change your percentile? So let's say there are top 3 people who scored 100 on 100 instead of 1. Instead of having different scores, they all have, the first 3 have the same scores. Then what is the percentile you'll assign to this 96th guy? Still, the number of people on the lower side hasn't changed. So he would still have 95 percentile. But what is his position in among the top 5%? Now he's third, right? Because there are 3 ties at 100, and then there is a 97, and then 96. So he's the third highest, right? Not the rank wise, but marks wise. Now let's say he had a different situation where, all the top 5 score 100 each. Right? Then this guy still has 95 people who have their scores less than his. So he's still the 95th percentiler. But, you know, among the top 5, he's actually a topper. He's the first. Because all the 5, the 5 people have the same scores. So that's the reason why we look at as a less than case than a greater than. Because in the greater than, the problem is I don't know how many ties that are happening. In the less than case, even if there are ties happening, that's not going to affect my position. They'll all still be less than mine. But if there are certain ties which are happening in the upper percent, that is going to shift my positions, my place. So I'm not going to have a very certain info just knowing that I'm among the top 5%. I need more information on that. But if I'm a 95 percentiler, right, as a less than case, then rest assured, I definitely have 95% of the people with their scores less than mine. How many of them get tied, I don't care. That does not affect my position in that case, right? So that's why percentile is seen as more of a less than case than saying, okay, I'm on the top percent. Now imagine a situation. See, that's so funny about the percentiles. Let's say, take a case where, you know, you have these 100 people who are preparing for the test, and say everyone got 100 on 100, right? Everyone scored 100. There are 100 students, right? And everyone scored 100 on 100. Say somehow the paper got leaked, you know, someone just, decoded that and just spread it there. So everyone got 100 on 100. Now, what are the percentiles that you will assign to each? So what is the percentile each one of them would get? Can think logically. So everyone has no one less than his score. All of them are the same. So there is no one which is less than anybody. So they would all get 100 percentile. Sorry, the 0 percentile, because there is no less than case possible. Although everyone scored 100% of the marks as a percentile, each of them would get a 0 percentile. Right? So in that way, you see the logic of percentile is different, from the percentage. Percentage is just about the number of marks that you score out of the total, whereas percentile is not about your score; it's about your position vis-a-vis the people, among the entire test takers, seen as the number of percentage of people who have their scores less than yours. Right? Is that clear now? Akshat, any doubt regarding the whole concept of percentiles? Okay, good. So now let's move on to the next one. Welcome. So we did these quartile things. I think we have completed that. Box and whiskers plots also. How many of you were not present in the last session? I see. Okay, this time, good number turning up. There were a couple of you who were not there last time. Okay, so I would be repeating that sessions, at least, the last couple of sessions, which some of you have missed because of your test and all that. So I'll just update that after I've checked out with my company, and they will communicate it to you. So also the sessions that will get repeated. So people who have missed on that, they can attend that. ये भी हो गया था, right? Which question we were on? Did we cover up this part? This was the last question, right? That we did certain computers, Hana? Okay, sure. Now let's go to the next one. Let's go on this one. Check this. Okay, try this out. Yeah, let's see in this. DAC. Uh, Now, this is a good question. This is a one tricky type that you would see on your normal distribution wala case. So let's say here, uh, let me just draw this. So if let's say my curve is going to be of this type, let's say this is how my normal curve is. Let's say what's going on. Now imagine if I'm taking a value here and then a value here and then a value here, okay, which are, let's say this is at an 800, a 700 and a 600, three values to it. Okay, now they are equal in the base. The base, if you could see, is at a gap of 100 each. Now if you look at the number of observations, which in this case would be seen as the area of the graph that it would lie in. So if you see, this covers, right? So let's say in this case the mean is 800, standard deviation is 200. So this is going to be your mu value, the mean, and 600 is going to be mu minus sigma, right? So this has a interval of kitna 200, and you would see the percentage of the observation that would lie in this entire group is 34%, as we saw in the last case, right? Total is 68% from minus sigma to plus sigma, which would be split as half and half, right? So there's going to be, x 34% on the left and 34% on the right. Okay, so you get a 34% here. Now the question is 700 going to split this, as a 17%? So think and answer me clearly. Is it going to have a percentage, split of 17 here and 17 here? Will the midpoint here also would split? This is the midpoint here. Would it also split the percentage of the areas equally? Exactly. Right side would have a higher value, right? This should have a larger percent. This one should have a lower percent. Why? Because they have the same base, but the height is different. It's decreasing here, right? Whereas this is more or less increase and fairly constant. So this portion, if you would see, as compared to this, there's so much of a less area covered in this region along the graph as this region. I would have drawn a straight line. These are equal, x and x. Look at this is y and this is z. Your z portion, this whole, is much, much larger than this y portion, right? So I would not say that this midpoint would always going to split the area also equally. It will, have a larger area for the portion which is closer to the left, which is closer to the mean side. As you go deviate away, either on the lower or on the higher side, it is going to be different. Okay, so this is not going to be the same. It is going to be different. Now, if I want to make the area equal, what should I do? I should need to add more area on the lower side. So I need to shift, my sides somewhere along this, somewhere along this region, so that I take small portion of the area from the right side and add to the lower side and make it. So here, if I would say, you know, this is a point which will be, this whole is 50, and then this would be 50 minus 17, which would be 33rd percentile. Correct? Because there's going to be 33, and then this is going to be another 17, which will add up to make it more fat. So this is going to be somewhere around the 33rd percentile value, which will come. Right? So I need to split it out in such a way, if it's got a higher, got a greater height, then I have to have a smaller base. So as it moves close to your mean value, base should be smaller because it is going to have a greater height. As it's moving away from the mean, the base should be larger as the height is going to decrease. Is the logic clear? Right? That's a basic idea that we need to think it over. Now let's right now let's go to the question and then check. Now read it and then try it out. Just try once again and you will get to know. Okay? So here it says x is normally distributed. So I would just roughly different, draw that. So let's say this is the graph that we have. X is normally distributed. Okay. The value at the 45th, 15th and the kth percentile 500, 300 and 400. So ये थोड़ा 50 से कम, ये 45th है percentile value, and then at the 15th, say somewhere here, ये 15th हो गया. This is your 300. This is your 500, and somewhere here midway there is this 400, which is a 100 ka split. This is the kth percentile. Now you have to compare k with 30, right? Now at this point at 400, this k, this will not have this area splitting equal to this area, right? Significantly different है ना? So अगर equal percentile पे divide करना था, so equal percentile वाला would come somewhere here, close to this. जिसमें थोड़ा इसमें से cut किया, इसमें add किया. Now I can make their percentages equal of this region. इसमें से इसमें add कर दिया और. So this one will exactly split. ये 15 हो जाएगा, right? 45 है ना? And ये 15 है 45. So this total gap is of 30%. Right? 30% का split है 15th percentile and 45th percentile, where this point is splitting equally. So ये 15% हो गया और ये पूरा 15% हो गया. Right? So ये जो इधर point आएगा K. Okay. So ये 45 में से 15 गया. So this is going to be the 30th percentile value. This line. And you see the K is to the left of it. Right? So in this case, the kth percentile is to the left of the 30th percentile, जो उसको equally spread करना था, right? So therefore, K has to be smaller than 30. Not A. No. See, Akshat, it cannot be on the right side of the mean, no? Yeah, already 45th percentile is to the left of the mean only, no? Mean is the 50th percentile, no? It goes from 0 to 100, from left to right, correct? So the mean will be the 50th percentile. 40th would be to the left of it. 15th would still be to the left. So both these are going to be on the left side, right? So 50 के ऊपर जो percentiles हैं, the 60th, 70th, 80th, 90th and all that, they are going to be the right side of the mean. Whereas lower ones, right? 40th, and all that. 45th, 40th, 30th, 35th, they are all going to be on the left side. Is that clear? Okay, 1 minute. Just go for that. See if I could bring this out. This one. Okay, shall we move on to the next one then? All right, so let's go to the next question. I hope this is clear. Wait a minute, let me just. So the answer option should be B. Okay, I hope Akshat you are clear why we are taking it to the left side, not to the right side of the mean, huh? Okay, just be convinced about every step why we are doing. Okay, check this one. It's a good question. You know, this is on the idea of range and how do you actually use and manipulate the range. Okay, try this out. Good set of questions. Yeah, what is the answer here? D, only the first and the second one, right? Correct. It's a simple question. Again, more logical in nature than, applying the maths part. So what's given here, if you see, that the range of the height of class A student is 14.2. Now range is the difference between the lowest and the highest. So let's say this is class A, the shortest of A, the tallest of A. The gap between them is 14.2. Okay, that's the first. And of class B is 16.4. So 16.4, this is shortest of B and the tallest of B, right? Now, if you want to determine the range of both classes combined, that means if we merge the two, classes, A and B, you're gonna have a total of whatever the number of students you're gonna have. Now that will also have the shortest A of shortest B and the tallest A and tallest B. We need to see what is the relationship, whether who's the shorter among the two of A and B, and who's the taller among the two A and B, and accordingly, we can figure out the gaps between them and the other thing, right? So let's see which of the statement would help us in that way. This says the tallest student of B is 4.8 taller than the tallest of A. So this gives us a relation between the taller of A and the taller of B. So if I draw it here, we can look at this, situation of something like, let's say if this is the entire range of it, okay, of both the classes combined, right? So we start with the tallest. So tallest of B is 4.8. So I'll write this is the tallest of B, and then there comes the tallest of A. This is 4.8, right? Now from B, it's 16.4, and this is 14.2, right? So therefore, you're going to have the shortest of B coming first, and then the shorter of A. Because the difference between these two, you know, 16.4 and 14.2 is actually, you know, if you see this difference was, 2.2. And this is 4.8, so this is going to be coming first and this one, so this is going to be the order, right? Now we know that this gap, shorter of A to the taller of A, this is the entire band of A, which is 14.2, and this is another 14.8. So the whole difference in this case, you can say, is 14.2 plus 4.8, which is going to be 19. So if this was a PS question where you were asked to find what is this difference or what is the range of the combined class, not just to check whether the statement is sufficient, but actually to find the answer as well, then you would see the answers would be 19 centimeter or inches, sorry, in that case. So we see the first one is sufficient to answer that. So one is true. Now, instead of randomly going and then checking the others, I would just see, first of all, can I reduce on my cases? So one has to be true, right? So that takes out B, that takes out C, that also takes out E, right? So B cannot be the answer, C cannot be the answer, and E cannot be the answer. Now you need to just, guess between A and D. So if let's say you had this question as the last one, it's like the 20th question, and you're left with only, let's say, around less than a minute. I would have solved just the first condition, okay, instead of checking all the four, and I would have eliminated three options. Now I can guess between the two. So the chances of, me getting this right is, one out of two, which is 50%. Whereas earlier it was just one out of five if I would have randomly guessed it, which was just nearly 20%. So I increased my probability from 20% to 50%, which is like, 2.5 times, right? So 150%. So I increased it by 150%, which is quite significant. So just don't randomly mark. Try to eliminate the options even if you're short on time. Just eliminate some of the options and guess among the left ones. It gives you a good edge. Now, The only thing that I need to check here is between A and D is whether second is true or not. That means I don't need to bother about the third and the fourth at all. I can get away without checking them. That's not going to make any difference to my answer. If there was an option, your fifth option, which says all of these, then it was a problem. Then I would need to check at least the first three, if third would also turn out to be true, or the fourth one, right? But in this case I can simply eliminate, not even check the third and the fourth. I can save my time on that. Now let's look at the next one, you know the second condition. So again, if we combine, what we see, the shortest of B is 9.2 inch shorter than the tallest of A. So the shortest of B and the tallest of A. So I don't know where this tallest of A would come, but let's say if the tallest of A is here, because I also keep the possibility that B1 could be taller or shorter than that. We'll see that. So TA and SB, the difference between tallest of A and the shortest of B, this is given out to be 9.2, which is actually less than both, if you will see. Now TA to shorter of A is 14.2, and shorter of B to tall of B is 16.4. So 16.4 from here, has to be 16.4. So T of B should come here, and from T of A, the S of A is 14.2. So S of A should come here. Right. So we see that this gap is between this. Right. Now I need to find, okay, what would be the entire range. Okay. Now here, if this is 9.2, now T of A and S of A, this is total of 14.2. So from here to here, this is 14.2, out of which this is 9.2. So this one is 5, right? Because from 14.2 you took 9.2, this is 5, and from this to this, the total of this here, B ka part, this whole of B is 16.4. So we see the gap from here to here is going to be this 16.4 plus another 5. So if you have to find out the range from the second, it's going to be 16.4 plus 5, which is going to give me 21.4. So if it was again a PS question, where you need to mark, then I would also have one of the possibility as 21.4. That would be the answer for the second one. 16.4 plus 5, which is 21. So therefore your answer option D. Okay, I just solved it, for the sake of finding out the numbers or the values here. Otherwise, a small inspection of the first and the second statement is sufficient for you to deduce that D has to be the answer. Yeah, that would have worked out. All right, so good question eventually. But now just let's evaluate why the third and the fourth one would fail. So here you see that for the third one, the average height of B is 3.8 greater than the average height of, you know, A. Actually, it's not B and B, this should be A. So that's an errata. So just remember this point here, this should be class A, right? So average height of B is 3.8 greater than the average of A. Now, knowing the difference between the average will not help me out in any way, because in order to find the range, I should know which is the largest and the smallest. That info we don't get from the third. And again, the ratio of the heights of the shortest of A to the tallest of B is 5 is to 16. Ratios won't give me the numbers. So that would be the problem again. I would not have problem. I don't have the values there. So that's going to be the issue. That's it. Okay. So uh, the median, the difference between the medians again would be the midpoints, right? See, but you don't. What is asked is the range, correct? Now, if I would say A का median ये है, right? Say A का median of A, and then there is something like the median of B, and there is some relationship between the median of A and the median of B, right? I would still don't know what is the spread around the median. So median could still be here. You will have equal number of cases. So what I'm telling is the spread, not the number of observation. You will still have, let's say, 50% here and the 50% here, right? But what is the spread? Hmm, that we will not know from the median again. It's just like, the quartiles का thing. Uh, you will the, उसमें कितना किसी का equal spread भी हो सकता है, ज़्यादा spread भी हो सकता है. That's okay. That's okay. It's good. Okay. Right. Good. Ask questions. In fact, that's the best way of learning than reading through the books. When you ask questions, that's the real learning that you have. You always don't believe anything on the. If it's written in the book, doesn't mean it's always right. Question it. You know, convince yourself before you actually accept it. Okay, let's check this one. Try this. Okay, so what's the answer for this one? What is it that we got? D? Perfect. Issue? It's very obviously D, you can say that. The problem is we don't know exactly how many numbers, how many observations will have a tie with the mean value. It's not necessary that all the values are distinct. Nothing is given that all the numbers are different. So you can have one number which is spaced out quite far, but the others are very much equal to the mean. So that still the standard deviation of both of them may be the same. Say, for example, in the first case, the mean is 3 and the other is 5. You can have certain values of data which will be 3 in the first and 5 in the other, which will bring out the deviations to 0. But you can have a larger n or the larger difference from there, right? It just says the mean is the same, doesn't say the number of observations are also equal, and it doesn't say that the observations are all distinct. So you can have a lot many ties with the mean and hence change the deviations, the sum of the deviation, and still have the final standard deviation to be equal. So you can have a larger spread for the first, very small for the second. You can have a larger spread for the second and small for the first, ensuring you still have the same standard deviation. Can be manipulated easily. So hence straightforward D. All right. Okay, now this is a graph-based questions on stats. Okay, just be careful and look at the values in the graph before you answer them. Okay, check for this one. Okay, try this out. This is an easy set. Try it. So what's the answer we are getting to this? Okay, so if you count The total number of observations here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the average would be, the median would be the average of the 6th and the 7th. So 1, 2, 3, 4, 5, 6, and 7th, which is the average of these two. 63, 39. Right. So if you add 39 to 61, sorry, 61 and 39, it's going to add to exactly, midway here, which is 400. Right. So therefore, answer option C. So around 400, 369 is minus 39, and 439 is plus 39. So exactly spaced around the midpoint here. So therefore, this has to be the mean itself. So C. So just find the average and solve. Okay, that was easy. C is the answer. What's the value of the Q3? Okay, third quartile. I'll just quickly work out on the third quartile value. Check what is the third quartile in this. Third quartile would be the average, sorry, the median of the second half. So remember the median here is 400, right? So third quartile is going to be the median of this spread. The first quartile is going to be the median of this spread. So let's find the third quartile here, Q3. Okay, so 1, 2, 3, 4, 5, 6. It has to be a value which will split this into equal halves. So the average, the arithmetic mean of these two. Now let's quickly check and tell me what is the answer there. 764.5, option D. Right, that's the answer. 683, 7846. So it has to be slightly more than 750. You can just eliminate from the options even if you don't know. From 750, 683 is more closer to 750 than 846. So the average has to be definitely more than 750. 800 would be more closer to 846 than 639. It has to lie exactly midway, right? So these all can be eliminated. This is not midway. This is definitely not midway. This is the only value which looks like to be lying somewhere in the mid. Yeah, perfect. Correct. 9 2 से divide करके 0.5 आएगा. Right. So that's also good logic. Perfect. Right. And again, you can, see whenever you're trying to find arithmetic mean, it would be the midpoint. So you can see how it is balanced out. You can eliminate. Okay, perfect. D is the answer, right? So what is the interquartile range in millions? Now the interquartile range is the difference between Q1 and Q3 again, right? So what you see, either median is 400, either जो अपना आया था for, see, sorry, what was the value in the last one? I need to go back and check. 764.5. Right, okay. So this is going to be Q3, we already calculated, right? 764.5 Q3. Q1 find करना है, which will be the average of here. Is going to be Q1. Now just be careful with the numbers when you're finding Q1. Remember the first rule is that when you calculate, you need to arrange the data in the ascending order. Is the data accordingly arranged here? Right? So 238, 251, 252, right? Or 3 here. So this value is greater than this. So actually when you write, so 238, this is going to be a 251, and the third value has to be this, which is a 252. Right, so it should come as an average of 252, and this one, which is 278. Okay, so the catch here is when you look at this portion, to find out Q1, you need to shuffle the values because you have to arrange it in the ascending order. Okay, then accordingly find Q1 and take the difference. Interquartile range is Q3 minus Q1. Substitute and check and see what you're getting. If you see, it turns out to be 499.5. Yeah, C is the right answer. No. See, that's the catch, right? So you need to be careful. Although hardly marginal difference, right? It wouldn't have made very big difference. It would be a marginal difference, not so much in the answer. Okay, this is good. This is tricky. Check. All right, let's see. For this one, would he make it to his dream university? If he fails, would be a sad case. Typically, the answer option doesn't match as such what you see, you know, as a GRE question, because you won't have three options ever. It's either five or more than five, and then the other are the comparison ones, the box one possibly, where you will need to enter a value, but then again you need to add a number there, not a logical answer to that. Say this is the normal distributed, scores of that university thing. Yeah, the mean is 500, so somewhere here, somewhere exactly at the center, somewhere here, it's 500. And then standard deviation is 100, so let's say what standard deviation would come here. Okay, that would be 600. And then Tom wants to admit to the university. He has to have at least 67th percentile. And he's got a score of 585. So let's see whether, he's got good enough to make it to that university or not. Now 500, and then this is one standard deviation. So that's 600. Now observe, this area up to here would be 50%. Okay, and he wants to make 67th percentile. Anything at least 67th percentile. Now this interval is another 34%. So this is here at 84%. I want to get a 67. Now this 34 would have exactly half. If I split this, I would say the exact half would come somewhere here. If I have to count another 17% and a 17% if I have to split, because then this is going to be your 67th percentile, right? It's going to be 50 plus 17, and that's the only way I can make this area of a larger hump, equal to this smaller portion in here by fitting in a larger, broader base. So this point has to come left through 550, right? 550, because if it is 550, you have equal bases. So this has to be slightly more closer to the mean. So it should be slightly away from the midpoint of 500 and 600 using the same logic that we discussed in the the previous question. Right, so this has to be slightly less. So he's going to be a 550 here, whereas our dear friend, he has scored a 585. He's here. Slightly more closer to 600, give him a good representation. So his score is somewhere around here. That's 585 on the scale. So, everything outside this, if I just rub this off, these lines, so I can say that everything after this, is a favorable region, right? This is the favorable part, right? So this is the favorable portion. And we see that he lies in the favorable region, right? So therefore, the answer is a yes. Has 684, 500 is the mean, right? And then standard deviation is 100. So mu and mu plus sigma. So you see that, the spread between one sigma from the mean, the first sigma, that has 34% of the weight, 30% of the observations. So 50 and 34, which is 84. Is that clear? That's how I got that 84, Nikhil. Okay, mean tak exactly 50% hai on the lower side, and 1 sigma covers another 34%, right? So it goes to the right side of it. So 600 plus, that is 50 plus 34, which is an 84%. Is that clear? Okay, good. So see, this comes as a yes, right? Let's check. Oh yes, it's a yes. Okay, I hope it's clear to everyone. The same logic. If you have to make the areas equal, then you need to have a top tower having a smaller base and a shorter one having a broader one. Okay, although it goes contrary to the construction principles, the taller one should have broader bases in reality. So that's how it works. It doesn't work so bad. Just kidding. All right. Okay. So that's here. Let's move on to the next one. Right. Oh, that's the last question, in fact. All right. Okay. So that finishes with the stats part. Right. So we did, you know, so we actually covered mean, median, mode, range, and standard deviation, and quartiles in the first half, and we actually did a bit of normal distribution and application of range, and again the idea of quartiles to graph-based questions in the second half, right? So for all those guys who have missed down the first session and even the couple of previous session, okay, I'll try to do a reclass so that you guys don't end up missing on anything. In fact, I would like, if there have been 2 or 3 sessions that had a very low volume. So in case if you want to redo that, so Samyuk, and you can just try to do one thing, any one of you, Samyuk, Shantanu, whoever is your class representative, okay, he can just take a call, a consensus on what are the topics you would like to, go back and discuss what most of the people has missed, and just let me know by Tuesday so that I'll try to arrange a reclass on these. You would have a flow, so you would know which of the sessions you have missed. So please let me know, and then I would arrange, for a reclass of that. Right? Okay, so we can do that. Just let me know by max by Tuesday, and I arrange for it. Okay? Sure. So that's the end for the today's session. Let's sign off. Take care, guys. Stay safe. You have my number, so in case if you want to get in touch with me, please do that. Some of you have actually approached for me for the study plan. So guys, directly call karo na. We'll talk, and I'll work it out on that one. So in case agar kuch tumko extra material chahiye, so just come over. I'll share it out on the mail on that. Right? So in case if you want to discuss, just feel free to call me, fix up, and we can discuss and chat. Okay? Sure. Take care, stay safe, and study well. Exams are over, so the next thing should be, a target of at least a 335 on GRE with a 140 on quant, 170, sorry, on a quant section. 140. It's a minimum, sorry, the maximum, which is 170 on 170. Let's just go and crack that out. Okay? Sure. All the best. Take care. It's good night from my side. Bye bye.